Appreciate it. Well, good afternoon, everybody. Every IoT solution needs a network connection, be it cellular, Wi-Fi, LoRaWAN, or satellite. Now, for some solutions, one network connection will do, but to be truly global, a connected product sometimes needs 2 or even 3 radios to always have access to a network. But there's a problem with that. It's the problem of pain for us as developers and the reality of taxes. The pain that a second or third radio adds to an application and the 4 taxes that you have to pay every time you add a new radio to a device. The first tax is the hardware tax. And for every new radio, you're signing on to a new set of antenna requirements, new keep-outs, new supporting hardware, new radio, radiation, and noise variables to account for, and most importantly, a more expensive BOM. And given that wireless modules often represent a large chunk of a product's BOM cost, and adding another radio can be a very significant hit. The second tax is firmware. And here, the cost of the complexity is in managing multiple radios in your application. Because adding a new radio means that you're now in the business of building a complex state machine to monitor link status, detect an outage, retry just to be sure, back off, fail over to the next radio, and then the next, and do it all over again the next time that you need to make a connection. You're introducing an entire connection management subsystem into your application, into your business application, that then becomes quite brittle and difficult to test. The next tax is certification, because each new RAT and each new region requires another carrier certification at a minimum. So taking on a new RAT means a slip to your schedule and a multiplication of the SKUs that you have to support. And then finally, there's the access tax. Now, for some critical radio access technologies, you pay for a spot on the network each month, even if you never send or receive a single byte. Now, this is still true in some parts of the cellular world, though less so than 5 years ago as more providers offer a pure usage-based network access model. But it's definitely still very much true in the world of satellite, where accessing a satellite network often means you pay for a spot each month and you pay for the data that you transmit over the network. So given that satellite in IoT is most often used as a failover technology, that means you pay the access tax for the network, even if you never plan on sending a single byte. With these 4 taxes in play, is it any wonder that many of us tend to just give up, right? Many of us avoid multi-radio solutions, not because we don't need them, but because we don't need the hassle, right? We have just decided that we'd rather not be global if that's actually what it's going to take to get there. And so the promise of truly global, always connected solutions remains out of reach. But wouldn't it be better if instead adding a second or third radio to a project was as simple as selecting a new module that provided a consistent API from one radio access technology to the next? Or a module that handled failover and radio selection for you? A module with RAT-specific data shaping so you can serve bytes on constrained networks? Or a module with no additional carrier certifications, no subscriptions or commitments, and a pay for only what you use approach? The reality is that this is not a pipe dream. It's what we have been building at Blues for the last 5+ years. What we're building at Blues with the Note Card and Note Hub is a device-to-cloud data pump that's built to solve that messy middle piece of IoT connectivity, not just for one RAT, but for all of them. The Note Card is an embeddable system-on-module that provides cellular, Wi-Fi, LoRa, and satellite connectivity wrapped in a single developer experience. The embedded firmware actually provides automated transport management. It provides failover with data shaping so that you can save bytes on constrained RATs. And what's more, using the Note Card requires no additional carrier certifications, no commitments, no end-user provisioning, or complicated setup. You pay for usage across RATs like cellular and satellite, not for a slot on the network. And across every radio access technology, that data is routed through Note Hub, which is a device-to-cloud middleware platform that you can rely on for fleet management and for routing data to your ultimate cloud application. Now, our objective with the note card is to provide a true multi-rat model for those customers that are using Wi-Fi and cellular, or cellular and satellite, to provide a true support for multiple radio access technologies with automated failover and policy-driven message shaping that frees you from being a state machine puppeteer in your own firmware. The note card provides a powerful JSON-based API for all aspects of managing communication from your device, from synchronization policies to the shape of data and how often you sync to the cloud. And configuring something like utilizing multiple rats is as simple as making a single JSON request that gives you the power of specifying which rats to prefer and in what order to use them. In this example, I'm telling the note card to start with Wi-Fi, then fail over to cellular, and finally satellite as a last resort. And I'm also configuring a recovery window of 30 minutes before the note card attempts to reestablish primary connectivity. And truly, the note card takes care of the rest. This is all that I need to do to get the benefit of multi-rat failover and support. I don't have to manage that state machine myself in my own application. What's more is that when your device is in failover mode, the note card provides a similar mechanism for ensuring that you save bytes by sending only the data that's absolutely necessary when you're on a constrained radio access technology like satellite. So for example, if I'm building an asset tracker for long-haul trucks that occasionally loses cellular connectivity along a route, I can specify a template that sends a complete payload including truck location, speed, and condition data when on cellular. Costs me about 144 bytes. And then a second template that sends only location data and time as a heartbeat when the device is connected over satellite, costing me only about 13 bytes. So 10% of what I would send over cellular, and I have that option. Again, this is automated. This is automatic as by nature of using the product itself. So this model has actually proven quite powerful for our customers, and is something that we first enabled with cellular and Wi-Fi in 2023, and then enabled with satellite in 2024 with the launch of StarNote for Skylo. StarNote for Skylo is an accessory and a note card companion device that enables product builders to add NTN satellite with the Skylo network to any note card-based solution. So with StarNote for Skylo, we provided a fallback-friendly satellite module with no additional carrier certifications and pay only for the data you send approach. So there's no end-user registration or provisioning, and there's no subscriptions or commitments beyond that. This was a really popular product when we announced it in 2024, and one of the things that we heard from customers when we launched it, because that's a module that's used separate from the note card, is, this is really great. We're very happy you actually already provide a note card for us that has cellular and Wi-Fi in a single SOM. Wouldn't it be great if you could provide cellular, Wi-Fi, and satellite in a single module for us? And we agree. And so what I'm happy to announce today that we actually have that product that does exactly that in the note card for Skylo. So this is a single module in the note card form factor that includes Cat-M, NB-IoT, GPRS cellular, Wi-Fi, and NTN satellite provided by the Skylo network. There's no need for a second module, and it's a 3-in-1 that can be dropped into any existing product, any existing note card-based solution, be it cellular, cell plus Wi-Fi, et cetera. And and it uses the exact same developer experience and API as any other note card. So this is a product that's actually available, and again, there's no subscriptions or commitments for this as well, just like there is for StarNote. This is in beta today, and so you can scan the QR code on the screen to join our beta program. You can also come and check it out in our booth at A17. So we were excited about this. We have a lot of customers that are raring to go and ready to use this product. One of the other things that we heard related to our satellite announcement last year was many of our customers that are, especially those that are in industries like shipping, logistics, and agriculture, are in industries that live at the edge of the internet, sometimes beyond the edge of the internet, for long periods of time. And those customers asked us, wouldn't it be great if Blues had a single satellite module that provided truly global pole-to-pole coverage for us? And again, we agree. And so I'm also excited to announce today that we have another product called StarNote for Iridium. And this is an accessory and a note card companion device similar to our StarNote for Skylo, but it provides global pole-to-pole satellite connectivity powered by the Iridium network. And much like our other note card companion devices, much like our other satellite modules, StarNote for Iridium offers fallback-friendly satellite with no subscriptions or commitments, and to pay only for the data that you use approach. What's interesting about using StarNote for Iridium is that it's possible to send tracking updates from the note card, and those messages will cost less than 1 US cent. So you can build a satellite failover device that is literally dirt cheap to be able to provide essential information over the network. We think that that's really quite powerful. And much like any other, much like StarNote for Skylo, this is a device that as soon as you connect it to any cellular or Cell Plus Wi-Fi note card, it recognizes the device and starts using it as a new radio for transport. StarNote for Iridium is also available in beta today, and we expect it to be commercially available in early 2026. And so you can scan this QR code on the screen, or again, come and visit us in booth A17 to learn more about the product. So, how does this multi-RAT model actually work in practice? We've talked about cellular, Wi-Fi, satellite, all of these things working in concert together. You might wonder, what does this actually look like? And the reality is that it works exactly as you would expect a multi-RAT or a multi-failover technology to work, but you didn't have to do all the heavy lifting in order to do so. So let's say as a practical example that I have a device here that's attached to a container payload. It's part of a shipping container. And it's a device that includes a Cell Plus Wi-Fi note card and a StarNote for Iridium. And what I've done is I've configured the device to prefer Wi-Fi first, fail over to cellular, and then if cellular is not available, use satellite. This is the exact same JSON snippet that I shared a couple of slides ago. So when the container is loaded, my device is connected to the Wi-Fi network, and it sends a message every 2 minutes. What then happens after that point is the container is put on a truck, and at that point it loses its Wi-Fi connection as the truck drives away from the facility. And at this point, it sends information every 15 minutes instead of every 2 minutes. Maybe a different message, it might be the same message, but the device automatically fails over to cellular. Now, at my next stop in the journey, the package goes onto a train, and that train is going to make a multi-day journey, at which point there will be several hotspots where cellular is completely lost. And so at this point, when the train when the train can access a cellular network, it'll send the message every 15 minutes. But when it loses that connection, it'll send a heartbeat message over satellite every 4 hours until a connection is reestablished. The train then makes it to its destination. The container is loaded onto a truck where it reestablishes cellular connectivity. And then it finally makes it to its destination facility where it's back on Wi-Fi as the truck is being unloaded. And everything that I just showed here is possible for you to build in an application with less than 10 lines of code. There's no actual firmware that you have to write beyond the messages that I showed earlier to manage all of that work with backoff, with hysteresis, with dealing with those network connections as they fall out. We think that that's quite powerful. So regardless of which combination of devices you use, whether it's the note card cellular plus Wi-Fi, whether it's Cell Plus Wi-Fi plus the StarNote for Iridium, which gives you 3 radio access technologies in one, or whether it's the new note card for Skylo, they all provide you with that same benefit and keep you from paying the 4 taxes that we talked about earlier. You get reduced complexity by managing additional RATs in your hardware, reduced complexity in your firmware by removing the burden for manual state machine management, no additional carrier certifications needed to expand your RAT footprint, and finally, no additional subscriptions or carrier commitments. You pay for the data you transmit, not for a slot on the network. And as a result, you get out of the business of paying those 4 taxes, and you can actually build and deploy truly global IoT solutions. So if you're interested, or even if you're skeptical, I'd love to prove it to you. I'd love to show you more. You can either scan either of these QR codes to join our beta program, or come by booth A17 to learn more. Love to show it to you, hear what you're building, and see how we can help you. Thank you.